Okay, next equation. So we're going to pick two equations and we're going to eliminate one of the variables. And again, it doesn't matter what two equations and it doesn't matter which variable. So you just kind of look through and see which one looks like it might be easiest to do. Okay, I think my first two equations, I'm going to use the top and the bottom. And I chose those because if you look at the x's, they already have a 1 as a coefficient. So I'm going to multiply the top equation by -1. So now it's going to be a negative x plus 3y minus z equals -1. I'm going to leave the bottom equation the same. And now I'll be able to eliminate the x. So I have opposites. I can add them up. The x's will go away. I'll have 5y's. I'll have -4z's. And I'll have a -2. Okay, so now I'm going to pick two other equations and I'm going to eliminate the x's again. So I think this time I'll pick those two equations and I have to eliminate the x's. So that means that I should multiply the top equation by a -2. So then I'll have -2x plus 6y minus 2z equals -2. And I'm going to leave this equation the same. And now that I have my x's as opposites, I can add them up. So the x's will go away. I'll have 5y's. I'll have -4z's. And that will be a 0. Okay, so now I'm supposed to take these two equations and put them together and solve, because now I only have two variables and it's easier to handle just two variables. So let's say I want to eliminate the y's. I would need one of them to be a +5 and one of them to be a -5. So I will multiply the top one by -1. So that'll make it a -5y plus 4z equals 2. I'm going to leave the bottom equation the same. 5y minus 4z equals 0. And I can add them up now because I have opposite coefficients in front of the y's. When I add them up, those will be 0. And when I add these up, those will be 0. I'll have nothing over there on the left. On the right, I'll have a 2. Those don't equal one another. So that means no solution. When a number does not equal another number, that means no solution. Next thing I want to show you is this formula. If you ever have any problems dealing with vertical motion due to gravity, meaning like you're throwing a ball up in the air and it's going to come back down because of gravity, this would be the formula you would use. SO is the initial height. So if they tell you that someone is throwing a ball and that ball starts getting thrown at a height of 3 feet, that would be your initial height. The v sub 0, that's the initial velocity. That would either be a positive if it's going up or a negative if it's being thrown down. And then A is acceleration due to gravity. And that is a set value. That's either going to be -9.8 meters per second squared or -32 feet per second squared. It just depends on the units. And then S at the end here This S is the height after a certain time, after any given time. So there's two S's. This is the initial height, SO is the initial height. This is the height at any given time. So if the ball goes up and then comes back down and hits the ground, here's the ground, this x-axis could be time, and the y-axis would be height. So at any given time, let's say here, any given time, we can find the height. So that's what this S would be right here. Okay, so you're going to be given a problem, maybe something like this. And they'll say, after 1 second, it's at 52 feet. And after 2 seconds, it's at 52 feet again. And after 3 seconds, it's at 20 feet. And this is the equation you're given. So how can that happen? How can you have two different times but have the same height? Well, let's look back here. Here's that height, that particular height. It can happen at two different times. Do you see that? That's kind of what's happening in this scenario. But the main thing you need to do is just plug this information in. So we're going to get a series of equations. If I plug in 1 for t and 52 in for s, hang on a second. So 52 goes in for s, and we're going to plug in a 1 in for t. That would be one equation, and I could rewrite that. I could do 52 equals, because 1 squared is 1 and 1 times 1/2 is still 1/2. So I could write it as 1/2 a. I'd have 1 v sub 0 and I have an s sub 0. That'd be one equation. That's an arrow. Okay, my second equation, s is 52. But this time, we're going to plug in a 2 for t. So if I rewrite this equation, it'll be 52 equals, well, 2 squared is 4, 4 times 1/2 is 2, so we'd have 2a, we'd have 2 v sub 0's, and we'd have an s sub 0. And then my third equation, we plug a 20 in for s, and we're going to plug in a 3 in for t. So that equation will now be 20 equals 3 squared is 9, 9 times 1/2, we'd have 9/2 a, we'd have 3 v sub 0's and an s sub 0. So our variables are a, v sub 0, and s sub 0. And we have 3 equations, so now we can solve just like we would do in a problem like this, or a problem like that. If you don't like the a, v sub 0, and s sub 0, you could replace it with x, y, z if you prefer that. Okay? And the last thing I just wanted to show you is just a visual aid. The fact that we're dealing with planes. So going back like here, these are 3 different planes, and those 3 planes intersected at this point. So the picture that would kind of represent that scenario would be like this. So the pink plane, the blue plane, and the orange plane, 3 different planes, they intersect at that point right there. You could have parallel planes, no solution. Well, that's what happened back here. They were parallel planes. We got no solution. So it's just kind of like a little visual, that's all. Okay, so that completes the video. Go ahead and work on 7.3 day 1 assignment, and I will see you tomorrow. Okay, bye.